All right, thank you everybody who's made it to this class. So in this lesson, we are going to look at exponents and radicals. We're going to look at exponents and radicals. So we'll start with exponents first. We start with exponents. We want to understand what are these exponents. So an exponent just shows us how many times a number is multiplying itself. How many times a number is going to be multiplying itself. So here we have a general term where we're saying that number b, and the number b, we are calling it our base. So the number is called the base, and what is here, the power, is what we are calling the exponent. So this power or this exponent shows us how many times this number is multiplying itself. So the n here, which is always has to be an integer, of course, an integer, then b we're saying is just a real number, it is then showing us how many times this number is multiplying itself. So this means that if b is raised to the power n, it means that b is multiplying itself n number of times. That's n number of times. Whatever number of times I can put there is what it is multiplying what itself about. So we are going to say if we have b raised to the power n, we will say that it is b to the nth power. So b raised to the nth what? To the nth power. But then for b raised to the power 2, we just say this is b squared, and then b raised to the power 3 is going to be b cubed. So this is what an exponent is. But now, what is important about the exponent is understanding these, what you see here, which are the properties of exponents. So these here, we'll look at each and every one of them before we then jump into an example of how to apply these exponents. So now, the properties of exponents. So if we have a real number a, if we have just any real number a and b, we are saying, and also we have m and n are positive integers. So letting m and n being positive integers, then we'll have the following what? The following properties. But of course, before I talk about these following properties, let me mention this, that we know these properties, which of course it is part of it, which we're saying any number that is raised to the power 0, any number raised to the power 0 is going to give us what? 1. So this is the first thing we look at. Any number raised to the power 0 will give us what? 1. Then any number raised to the power 1, any number raised to the power 1 is just that itself. So b raised to the power 1 is just going to be what? It's going to be b. Okay, so any number. So if I have 2 raised to the power 0, it's going to be what? To be 1. I have 2 raised to the power 1, it's going to give me what? 2. I have 3 raised to the power 1, it's going to give me what? 3. So any number raised to the power of 1 is that number itself. Any number raised to the power of 0 is what? Is 1. So we take note of what? Of these two. Okay, now let's jump into these here that I have. So we have that if you have b, so we're saying these are just any two real numbers, like b is a real number and a in this case is a real number, and m and n are just integers. So if I have b, so if b to the power m is multiplication, this dot here is just dot multiplication. So b raised to the power m and b raised to the power n, these here are just going to be equal to, so this property tells us that we'll keep the base. So if they all have the same base, we'll keep that base, and what we do is we add the numbers in the exponent. So we're going to add the numbers in the exponent. So we'll add the m plus the what? Plus the n. So this is what this property is telling us. So if I have, for example, we have 2 raised to the power, we have 2 raised to the power 5 multiplying by 2 raised to the power 3. So if I have 2 raised to the power 5 and multiplying this by 2 raised to the power 3, this then means that I am going to keep the base. So the base in this case is what? Is 2. So I keep the base and I'll add those numbers in the exponent. So I'll have 5 and I add plus what? Plus 3. and this here gives me 2 to the power 8, and 2 to the power 8, if I put this on my calculator, I just have, this will give me 256. So what that means, 2 raised to the power 8 just means we're multiplying 2 by itself 8 times. So that would be 2 multiplied by 2 multiplied by 2 multiplied by 2. I think you get it, up to 8 times like that. So this is what it means. Then this is how this property is what is applied. Okay, let us look at the next property. So the next property we have is, if I have b raised to the power n like this, and then I have m there. So what this means is that I am just multiplying the what? Multiplying these exponents here. So this here is just going to be equal to b, that's mn. So mn, we know that when they follow each other like this, it just means multiplication. So this just means that I'll multiply the m and the what and the n. Again, we get an example. Let's say we have 5 raised to the power 2 like this, 5 raised to the power 2, and I have a 3 there. 5 raised to the power 2 and I have a 3 there. So what this means is just I should do 5, keep the base, and multiply what's the exponents. So I'll have 2 multiplied by what? By 3. And this here gives me what? 2 multiplied by 3 just gives me 6. So 2 multiplied by 3 gives me 6. And this 5 to the power 6 is just going to be, if you plug that, that will be 15,625. Okay, but the point is that if you have numbers or like this, what you're doing is you're just essentially multiplying those exponents. Okay, let's move on to the next property. So the next one, we have that, which is this one, number 3. If I have A and I have B like this, so A and B, take A and B are not equal, they are different numbers. So if I have them raised to the same power n, I can distribute that power n to each and every real number there. So I'll distribute to A, I'll have A to the power n, and distribute to B like that to the power n. Taking an example, 2 raised to the power. So if I have 2, okay, let me say, if I have, let's say x, let's say we use x. So if I have x to the power 2 and I have y to the power 3 like this, then I have a 2 outside here. So what this then means is I can multiply this 2 to the x to the power of what? Of x, and also to the power of y. So if I multiply 2 by 2, there will give me what? Will give me 4. So I have x to the power 4. Then I multiply the 2 by the 3 there, that gives me 6. So I'll have it like this. So when we have two different numbers or two different bases like this, you can just distribute or multiply to each and every one in the exponent like that. Okay, so the next property that we have, number 4 here, is just telling us if I have A over B like this and I have n, I can distribute this also. So I can distribute in the denominator and in the numerator. So in the numerator, I'll have A to the power n, and in the denominator, I'll have B to the power what? To the power n, like that. So this is provided that B is not equal to what? To 0. So this B here should not equal to 0, because if it's equal to 0, we have something that is undefined. So this is what this property is what is telling us. Okay. The next property is telling us that if you have B to the power n and B to the power m like this, so there's division here. So B to the power n over B to the power m. So this here is just going to be, I keep the base, so my B is my base. Then I get the one which is in the what? Numerator, which is n. Then I subtract from what? The exponent, which is in the denominator, which is m, like that. Of course, this is also provided that what? That B is what? Is not equal to 0. So this is what this property is what is telling us. And this is, of course, we'll see even as we look at an example. Let's say we have 2 to the power, we have 2 to the power 5 divided by 2 to the power what? To the power 3. So this here just means you keep the base, which is 2, then you get what is in the numerator, which is 5, then you subtract from what is in the denominator, which is 3. And this here is going to give us 2 to the power 2, like that. And 2 to the power 2 is just 4. Okay, so we can also check that this is true. We can prove or check that this is true if we have, so 2 to the power 5 just means I'm multiplying 2 by itself 5 times. So that'll be 2 times 2 times 2 times 2 times 2. So that's what I have in the numerator. Then in the denominator, you have 2 multiplied by 2 multiplied by 2, like that. And then when you see now here, if I start canceling out, this one goes with this one, I divide, this one goes with that one, this one goes with that one. What I remain with in the numerator, I just remain with 2 multiplied by 2. And 2 times 2 is just 2 to the power 2. And this here is giving us what? The 4. So this proves the property which was just from what? From showing. Okay, let's go to the next one. So the next property is just telling us that if I'm dividing b to the power n over b to the power m, and so this, okay, to the power that does not look like a power. So we're saying b raised to the power n and b raised to the power m, like this, is going to be equal to 0 if and only if my m is equal to what? To n. So if the exponent here is equal to the one which is down, this is going to give us 1. So if I have 2 raised to the power 3 here divided by 2 raised to the power 3 here, this is going to give me 1. And of course, I can show from the property, using the property which we've just learned, we can say we keep the base 2, and then in the numerator we have 3, and in the denominator we have what? We have 3, so we're subtracting minus 3, and this gives us 2 to the power what? 0. And we learned at the beginning that any number, so 2 here raised to the power 0 will just what? Give us 1. So any number raised to the power 0 will give us 1, and which is what? The one which we have here. So that's what that property there is stating. Okay, then the next property just says if I have b to the power n over b to the power m, it's going to be 1 over b to the power m minus n if my n is less than what? M. My n is less than what? M, then I'll have this. Okay, so how do we prove this? So we can check by an example. If I have 2 raised to the power, let's say 3, then down there, I have 2 raised to the power 5. If it's so, let's check this what property. So this here, from the property we've learned, we said that this here is just going to be what? It's going to be 2 to the power 3 minus what? 5. But this here gives us 2 to the power negative what? Negative 2. Now, there's another property which we are supposed to state, which is if I have 2 raised to a negative, if I have a number, of course, not 2, but any number, so we say b raised to the power what? To the power negative n. B raised to the power negative n. This is going to give me 1 over b to the power n, like that. If I have b to the negative n, I just get 1 over b to the negative what? To the negative n. So what this then means, this is just going to be 1 over what? Over 2 to the power 2. 1 over 2 to the power 2, which is going to be equal to 1 multiplied by 2 times what? 2, which is 1 over 4, like that. So this is what this property is. What is telling us this property here? So what we can do, so let's use that property. Let me erase this. We just follow the property, what it's saying. So if I have that to the power what? The power, if I have n less than m, so if this here in the numerator, the exponent in the numerator is less than that in the denominator, what I do, I say 1 over, I keep my base, then I get the power or the exponent which is greater, which is 5 there, and then I subtract from the one which is less, which is 3, and this here will give me 1 multiplied by 2, then this will be to the power 2, which is just 1 over what? 4, which is exactly what we did based on the other property which we learned. Okay, so I don't know if there are any questions so far on how we use these properties. So we'll be using them even as we look at the following, the next examples we are to have. Any question? Okay, there's no question. So let us move on. So we've already talked about this property here. It's the one I was trying to explain. Say if I have b raised to the power n, this is just going to be 1 over b to the n, provided that b is not equal to what? To 0. Okay, so this is that property. Now let us look at the following examples. Let us look at examples and how we do this. So they're telling us to simplify. So the first one, we have 3 and then x squared y to the negative 4, like this, multiplying 4x negative 3, and then you have y like that. Okay, so here now they're telling us to simplify this. So how are we going to simplify this? So we can see that we have x and we have y here. We also have x and we have y here. So those bases are the same. But we know that when we have numbers or we have values like this in brackets, they just mean I'm multiplying. So this is multiplication that is happening here. Multiplying this first part with the second part. So what I do is with the numbers, so I have 3 here and 4. Those will multiply directly. 3 times 4 is just 12. So I have 3, I will have 12 here. Since 3 times what? Times 3 times 4 is just 12. Then I have what? A base of x and y here. So I have a base here also of x and y. So I'll write that base. So for x, it's going to be, so x, then what we said, if you're multiplying, what you do, you keep the base and you add the what? The exponents. So the exponent here, you have a 2. So on this part here, we have a 2, while else there we have a negative 3. So we are going to what? To do that. So we have a 2, then what? You're going to add. So adding plus negative what? Negative 3. Adding plus negative 3 like that. Then you have y. So y, then you have negative 4 with y. Then you're adding plus what? Anything here, if they don't indicate, it's just y. It means it's raised to the power of 1. So that will be plus 1 like that. And this here is going to give me 12. So x, here you multiply positive by the negatives, gives you a negative, and you just have 2 minus 3, which is negative 1. Then you have y, here you have negative 4. Negative 4 plus 1 will give you negative what? Negative 3. So this is what you have. Now, from the property which we learned, that b to the negative power is just 1 over b to the n, like that. This then is just going to be, I'll have 12 remains there, but the x, because it's raised to the power negative 1, it will be written as x there. And then here, y to the power what? To the power 3, like that. Okay. So this is how you simplify. This is how you simplify. I don't know if there are any questions on how we've gotten to our answer. Is everybody clear? All right, so let's continue. Let's do B. So B here says you have negative 2y to the 5th power and to the power 5. So what do you do now? So from the property which we learned, that if I have a number here and I have another one there, what I can do, I can distribute this power here. So I'll distribute. So I have negative 2. So negative 2 is going to be raised to the power what? To the power 5. And I have the y here multiplying 5. So the 5 and the 5 will be multiplying. So this will be multiplied by 5. So I've distributed like that. Now here 2 raised to the power 5. 2 raised to the power 5. So it's negative 2 raised to the power 5. So this means I'm multiplying negative 2 times negative 2 times negative 2 times negative 2 times negative 2. That's 1, 2, 3, 4, 5. And this here gives me 32. Now, it gives me negative 32. So negative 32. So what you do here, if you have a number where there's a negative sign and it's raised to an odd power, it means you're always going to have a what, and it will be negative there. But if it's raised to the even power, so if we had negative 2 raised to the power 4, this here is going to give us a positive value. So this will give us 16. So this is the same as 2 to the power what? To the power 4 like this, which is also what? 16. But then if we have it raised to the negative power, it's going to give us what? A negative sign there. So negative 2 raised to the power 5 like this is going to give us negative 32, which is different from us having 2 to the power 5, which is what? 32 like this. So you keep that in note, that if you raise the negative to an odd power and the negative sign there, it will just give you a negative sign. So to give us negative 32, and here you have y, which is 5 multiplied by 5, that gives you 25, like that. So this is what you get. Okay, let's proceed to the next question. So the next one, you have a to the power 2, and then raise 7 there, then divided by b to the power 4, and then you have what? 7 there. So here what you do, you just multiply those powers. So you have that multiplied by that, that will give you what? That will give you 14. 2 times 7 is 14. Then you have b to the 4 times 7 gives you 28. So you have it like that. So this is going to be your answer. Since they are of different bases, so we leave it here. We can't do anything about it. Okay. Then next we have negative 56. Then I have negative 56. Then I have x to the 9th. And then I have 7. Then x to the 4th power. So this is what I have. So what do I do here? So I can divide. The 7 divides into what? Into 56. The 7 can go into 56. That is 8 times. So it goes into 56 8 times. So I have 8 here. Then what we said when we were dividing, you keep the base. So I have x. The x and the x here, that's the same base. So then you get the one in the numerator, which is 9, the exponent in the numerator. You subtract it from that which is in the denominator, which is 4. And this here just gives us, also there's a negative sign here because we divided by negative 56. And this here gives us, this will be equal to negative 8. Then this we subtract gives us 5. So it simplifies to this. Okay, so this is what we get. All right, let's look at the next set. So the next question, E is telling us this question here. You have 12a squared b squared, then divided by negative a, negative 1 like that. Then you have b to the what? 5th power like that. So what are we going to do? So you can divide this negative 3 can go into what? Into the 12. So that will give us negative 4 if it divides to the 12. Then I have a, so a, then I'll keep the what? That's the base. Then the one in the numerator, you have 2. You have 2. Then since we're dividing, so we'll be subtracting minus. Then in the numerator, you have a negative 1. So that'll be the negative 1 will come here like that. Then you write your b, you keep that base. Then you have that, you have 2 there minus the what? Minus the 5. So you could have done this, or what you could have done with the b is you just say b, just say this will be 1, b, then you say 5 minus what? Minus 2. Then this here just will give you 1 over b to the power what? To the power 3, which you see we'll get even from here. So we have negative 4. So the negative by the negative gives us a positive value of, so it becomes plus. So you have a 2 plus 1, which is 3. So you get a 3 here. Then you have what? B here, subtract, you get a what? A negative. So this gives you negative what? Negative 3. And this here is going to be negative 4, a to the power 3 like that. Then this here I can write, so multiplied by 1 over b to the power what? 3. And this here just gives us negative 4a to the power 3 divided by 3b there in the what? In the denominator. So I'll have this as my answer. Okay, we look at F. Let's look at F. So if you have 2 to the negative 3 like that, plus 3 to the negative 1. So how do we do this one? So we can write this. This we can write as 1 to the power 2 over 3 plus 1 to the power what? 3, since it's only raised to the power 1. And this is going to be 2 times 2. So 2 times 2 times 2. So 2 cubed is just what? 8. So you have 1 over 8, then plus 1 over what? 3. Then you can make this into a what? A single fraction. That is by finding the lowest common denominator. So the lowest common denominator of 8 and 3 is 24. So you have 24 here. So 24, 8 divided into 24, 8 divided into 24, that gives us 3. Then 3 divided into 24, that gives us what? That gives us 8. So when I divided the 8 here, you multiply by the 1, it just gives you 3. This 3 divided into 24, it divides into there 8 times. 8 multiplied by this 1 here, that gives me 8. So this will be plus 8. So 3 plus 8, that just gives you 11. Then you have 24. So this is our answer here. All right, let's look at the last question here. Let's look at the last question. So the last question, we have 5x to the negative 1. Then you have y to the power 2 over 5x y negative 4, then to the negative 1. So what we do, we handle what's in the bracket first. So you see here, this 5 and this 5 can divide. Then I'm just left with what? With x, and the y that remain. So what I do, since they're of the same base, you have an x in the numerator and in the denominator, so I'll keep that x in the what? In the I'll keep that base. Then we have negative 1 in the what? In the numerator. Then in the denominator we have a what? We have a positive 1. So that is, okay, let me do this. Okay, so that is minus. So we'll be subtracting since it's in the denominator. So minus what? Minus 1. So negative 1 in the numerator, in the denominator I have a minus 1. Then y in the numerator, the exponent is 2. In the denominator, it's negative 4. So that's minus, since it's division here, minus the negative 4, which is there. Then the negative 1 comes outside there. So then next, this is just x to the negative 2. Then this here, when I multiply, this becomes positive. And it becomes, so it will be just 2 plus the 4, which gives me 6 like that to the negative 1. Then what can I do here? I can multiply this negative 1 to each and every exponent there. So negative 1 multiplied by the negative 2, that gives me positive 2. And the y multiplied by negative 1 gives us negative 6 there. So the negative 6 multiplied by the negative, I mean the 6 multiplied by the negative 1 gives us negative 6. And this is just going to be equal to x squared, then the y to the power 6 there, like that. Okay, so this is how you handle exponents and simplifying using exponents. Right, I don't know if there's any question. Okay, so let's move on now to looking at radicals. So radicals or surds, we're just saying that these here have a what? Have a presence of a root or a radical, which is not, or which is usually, which is not a what? Is a perfect root. So you have the things like square root of 2. You can't really, this has no perfect square. So such an example, or the root of what? Of 19, like that. They don't have a perfect square. Unlike when you have the square root of 4, you know the square root of 4 is 2, but the square root of 2 is like 1 point. It's continuous going up to that. It's an irrational number, as we looked at earlier. Yeah. But so now the basic rules which we have for this one is that if I have a number, so if I have two numbers, or not exactly two numbers, but if I have a number represented like this, A, B, where I can be able to separate the A and the B, it's okay to separate them as square root alone, square root alone. So what do I mean by that? So what we mean is, for example, if we have 6, if I have 6, 6 is just essentially 6 is 2 multiplied by 3. Since it's 2 multiplied by 3, then this is just, you can write this as square root of 2 multiplied by square root of what? Of 3. That's what that property is telling us. Also, when you're dividing, so if you're dividing, you have, let's say you have a square, you have 6 there, and you have 5 down, divided by what? By 5. So this here, you could write as the square root of 6 divided by the square root of what? Of 5. Of course, we're just saying that in the denominator here, it should not be equal to what? To 0. So now we have these examples here. They're telling us to simplify the following. So how do we simplify the following? So now, key in simplifying radicals, what you want to do is you first want to see if can you get a perfect square from there. So the way we have here, okay, let me erase this part, use this upper part. The way we have the square root here, square root of 12, they're telling us to simplify this. So from the square root of 12, I can get a perfect square where I say I have 4 multiplied by 3. So 4 multiplied by 3, I can write by that property 1 which we've learned as the square root of what? Of 4 multiplied by the square root of 3. So the square root of what? Of 4 is just 2, and you have 2 square root of what? Of 3, like that. And you have simplified just like that. Okay. The next one, we're simplifying square root of 20 here divided by 2, square root of 20 divided by 2. So in the 20 there, can I get a perfect what square is what you're going to ask. And of course, you can get, so here we will have that if we have a square root of what? Square root of 4, so 20 is just 4 multiplied by 5. So multiply by 5, then you divide by 2 here. And this is going to be square root of 4, square root of 5 divided by 2. The square root of 4 is just 2, and you have a square root of 5 there, and you have your 2. So you divide this 2 into there, and then you just have the square root of 5. Like that, you have simplified. Okay. We do the last one for our example. So the last one we have, so you have here, it's saying 5 square root of 6 minus 2 square root of 24 plus the square root of 294. Okay, so with this, what you always want to do first is you have these numbers here. So if they give you 1, like here you have 6, and 6 here, you cannot get a perfect square. So what that means, and when you have other roots like this, it means that the simplest form or simplest radical which must appear must have what? 6 in it. So it must be root of what? Of 6. So even in these others, it's what you're trying to find or trying to simplify it in that form. So here you have 5 root 6. In the next one, 2. So you can write this 24. 24 can be written as what? 6 multiplied by what? By 4. 6 multiplied by 4. Then at the end there I have 294. So 294 divided by 6. This gives us what? 49. So you have 49 multiplied by 6. So you know this 49 will give you a perfect what? A perfect square. So you have, so this will be 5 root 6 like this. And then you have negative 2 here. Then you have root 6 like this. Then root 4 plus the square root of 49 9, then square root of what? Of 6. And then you're going to have, this will be 5, square root of 6. Then you have negative 2. This here gives you a 2, so it will be 2 here, you're multiplying, then square root of 6 like that. Plus, this here gives you what? 7, and you have square root of 6. Okay, so what do we get next? You have 5, square root of 6. So 2 times 2 gives us negative 4 here. So negative 4 root 6 plus 7 root 6. Now from here you can add. You can add, you can subtract. You can add and what? And subtract. So you have this. So what you follow, since they have the same radical, so I can what? I can add them. So you just consider these numbers in front and you keep the what? The radical. So the radical here, the root 6 what will remain, but then I consider these numbers in front. I have a 5, I have a negative 4 and a 7. So 5 minus the 4 gives me 1. 5 minus, so in short I have 5 minus 4 plus 7. 5 minus 4 plus 7. So this gives me 1 plus 7, which gives me what? 8. So I have a 8 in front here, and like that I would have simplified. Okay, I don't know if there's any question. Any question before we proceed to the next part? All right, so the next part, in short, we're just saying in general, in whatever that radical may be. So here we're looking at the square root. In the previous part where we just have the square root of a, b, like that. But now we're saying even to the nth root, whatever, maybe it is the cube root, like this, it is the fourth root, the fifth root, just like that. Every part of it, you can simplify like that. So now, how do we usually get these nth roots? So if I have, for example, if I have b raised to the power what? If I have b raised to the power 1, the power n, like that. If I have it raised to a rational number like this, 1 to the power n, this here is just the nth root of what? Of b to the power what? The power 1. Okay. If I have b to the power 2 over n, this here is just going to be equal to the root of what? Of the nth root. So the n comes here. What's down is the root. Then b, then the 2 there is the square, which will come here. Okay, so that's how I get. So you can have different values here. You can have 1, you can have 2, you can have 3 on the n, just like that. So if we had the way we had 2. So if you have 1 over 2, if you have b to the power 2 like this, the 2 there is the square root. The square root of what? Of 2. And we don't usually indicate the 2 there. No, we just start indicating when we are going 3 going what? Going up. That's when we start indicating. Okay, so that's about this. And then we have this numerator. What can I get in the numerator? I have that I can get in the numerator, I have what? I have 2. So I can get 2 there. Since there's what? There's 8. So this here, I can simplify. So this here gives me what? Gives me a 2, like that. And I mean 3. Then, so if you say cube root of 27, like this, cube root of 27, since we are saying you can spread this cube root all over. So cube root of 27, and this here will be cube root of what? Of 8 down. So this gives me a 3 there. Then there, what I have is, I have a 2 multiplied by 2 multiplied by 2. That gives me what? Gives me 8. So I have 2. So this simplifies to what? To 3 over what? 3 over 2. Okay, so we get back to this. And this one here is just going to be, now, the same way we are saying those properties can be extended to even when you have what? When you have cube roots like this. So when you have cube root of 108 like this one. So okay, so we'll simplify this by what? Using 27. So I think 27 divides into there. So 27 into there gives us 4. So here you have the cube root is going to be 27 multiplied by what? By 4, like that. So now you can spread the cube root. So you have cube root of 27 like that, and then cube root of 4 there. So of 27, the cube root is just going to be what? Is going to be 3. Then you have a cube root of what? Of 4 like that. So no matter what to the nth power it is, you can still simplify it in what? In that way. All right. And that's how you'd what? You'd simplify these involving what? The radicals like that. Now, there's the reason why we're learning all these radicals is that we come and apply them to what we are calling now rationalization. And in rationalizing, we will be rationalizing the denominator and the numerator, but we start with the denominator here and we look at what? We look at questions. So now the simple rules is if I have 1 over root A, if I have 1 over root A, the way I am going to simplify this or to rationalize this is multiplying by the root of A in both. Okay, so what we're saying is when rationalizing the denominator, we just multiply by what? If we just have 1 over that radical, we multiply by that radical both in the numerator and in the denominator. So here you multiply by root A divided by root A. So when you multiply a square root by a square root like that, the square root cancels like this and you just remain with what? With A there. So in the denominator, you remain with A, and this is 1 multiplied by the square root of A, which just gives us square root of A like that. Then when you are multiplying, this next rule is just telling us that when we're trying to find, or when we're trying to rationalize something in the form as A, you have a number A plus minus root of what? Root of B like this. It can be plus, it can be negative like this. What you do here, you're going to multiply by its conjugate. So the conjugate will have a different sign, from what you have. So you have multiply by A. So meaning if it was plus here, you multiply by what? The negative first. If it was negative, you multiply by what? The positive like that. And the root B like that follows both in the numerator and what? In the denominator like that. So it will be negative and plus there root B. Okay, so now let's apply this. So we have this question. Number 1, they're telling us to rationalize 1 over what? Root 3. So to rationalize 1 over root 3, what we are going to do is we multiply by what? Root 3 in the denominator and in the what? In the numerator. So you have root 3 here and you have root 3 there. And then this here in the numerator, meaning you just have root what? 3, and in the denominator, that and that goes, you just remain with a 3, and you have a 3 like that. So just like that, you have rationalized that one. Okay, so the next one, we rationalize 1 over root 3 plus 2. 1 over root 3 plus 2. So I'll just rewrite this as the number follows first that does not have a radical. So I have 1 over 2 plus what? Root 3. So here the sign that is there is what? Is positive. So if I have a positive sign, it means that I'll be rationalizing or multiplying in the conjugate by, so the conjugate here will have a different sign. So it's positive, meaning to have negative. So meaning I multiply by this 2 minus root what? 3, then 2 minus what? Root 3. So here, what we're going to be using is using the difference of two squares. So remember that you have A plus B multiplied by A minus B is the same as saying A squared minus B what? B squared like that. So this is what we do for what we have in the bottom there. So in the numerator, it will just be 1 multiplied by this, and that will be 2 minus root 3, then divided by, so here I'll just square that 2 like this to be 2 squared, minus, then I'll square the root 3 like that. So this gives me 2 here minus root 3, then divided by, then I'll just have 4 here. Then when I square that, so this 2 and that square root here will cancel and I'll remain with a 3. That will be a minus 3. and that just gives me 2 minus root 3 divided by 1, which is just 2 minus root 3, like that. So this is how I get my answer there. Okay, I don't know if there's any question on how we get to our answer. All right, so that's the question.
How did you end up with 2 minus square root of 3?
2 minus square root of 3 as the answer.
No, as how did you end up with 1 over 2 plus square root of 3 multiplied by 2 minus square root of 3 over 2 minus square root of 3?
Oh, you're saying, okay, so you're saying this part, right? Are you talking about this part?
Not really, the other one.
This one?
Now up, where there is 1 over...
This part?
No, the next part.
This one?
Yes.
Okay, so what we said, based on the rule which we just had. So here we have this rule 2 here. We are saying if we are going to rationalize the denominator or simplify when we're rationalizing the denominator, what we must do is multiply both in the numerator and in the denominator by the conjugate. So here what we did, our question is this part here. This is our question. And it's just 1 over 2 plus root 3. So now here, what is changing is in the conjugate, what to change is the sign. The sign will become negative. And by that rule, I have to multiply by the conjugate in the numerator and in the denominator. That's why we are multiplying by 2 minus the root 3 here, and there down also 2 minus root 3. Is that clear? How we got that part? Okay, is that clear? Okay.
Yes, it is clear now.
Oh, okay. All right. So is there any other question before we do the next one? Okay. So there's no question. So let's proceed. So proceeding with the next one. So our next question, we have root 5 plus root 2. Then I have root 5 minus root 2. So here what you do, you multiply by the conjugate to rationalize this or rationalize the denominator, as they said, the conjugate of what is in the denominator. So the denominator here is square root of 5 minus square root of 2. So my conjugate, meaning the sign here, will change from what? From negative to positive. So it will be square root of 5 plus square root of 2. Then there, square root of 5 plus square root of 2. So this is going to be equal to, so you have this and that. So now what this is saying is that this is multiplying by what? By itself. This is multiplying by itself. So in short, you have square root of 5 plus the square root of 2, then square root of 5 plus square root of 2. And we know you have to multiply this part by that, this again by that, that by that, that by that. So what do you get? So you multiply this by that, the square root cancels, and you just remain with what? With 5. Since they have the same base, they are so square root of 5, square root of 5 just gives you 5. Then 5 multiplied by what? By the 2 there. So this will be plus, next plus, then you have a square root of 5 multiplied by square root of 2. So you have square root of 5 multiplied by square root of 2. This here can be written as what? Square root of what? Of 10, as that property we learned earlier. So this will just give us square root of 10. Then next you have what? Square root of this square root of 2 multiplied by square root of 5. It's the same thing and gives us what? Square root of 10. So we write this here as square root of 10. Then you have this square root of 2 multiplied by square root of 2 just gives you what? 2, like that. Then this here, you can add this 2, the 5 and the 2 gives you 7. and you add these two here, they'll give you what? 2 root 10. So that's what I have in the what? In the numerator, I'll have 7 plus 2 root 10. Then in the denominator, since it's a difference of 2 squares, so I just get root of 5, I square it, minus the root of 2, then I what? I square it. And this here is going to be 7 plus 2 root 10. Then I'll have divided by, this here gives me 5, minus there gives me what? 2. And this will be 7 plus 2 root 10, then divided by what? By 3, like that. And this is my answer. Okay. Is there any question? Okay, so there's no question. Let's proceed. Is that a question?
Sir,
Yes.
there where it was square root of 5 multiplied by square root of 5. Why
Yes.
did we only get, yes, why did we only get 5 instead of getting a 25?
You say this part?
Where there is a square root of 5 multiplied by a square root of 5.
Okay, so this first part we have square root of 5 multiplied by square root of 5, right?
Yes.
Okay, so square root of what? Of 5 multiplied by what? Square root of what? Of 5. So, in short, what you're multiplying this square root of what? 5, like that, right? Hello, are you with me?
Yes, I'm getting you.
Yes, so square root of 5 multiplied by square root of 5, right? Like this.
Yes.
So you have square root of 5 multiplied by square root of 5. So now this is multiplication, and we said you can write this as root what? You can write them together. So it will be 5 multiplied by 5 gives us 25. But what is the square root of 25? It is just 5. That's the reason why we got what? 5 like that. Same with what? The 2 which we are getting here at the end.
All right, so I understand now.
Okay. Okay. So,
Me, I don't understand, sir.
okay. So let me explain again. Uh, Here, let me erase this part. Okay, let me write it here. So you have root. Every time you have a what? You have a number like this. You have a number that does not have a perfect square. For example, the same 5 we have. And I'm multiplying it by what? By the root of 5 again. You're multiplying it by a root again like that. So now by the properties which we learned. So if you have, for example, we said here 25. This 25, I can split it into what? Into 2 like this. So I can split it into 5 multiplied by 5. And this will be root 5, root 5. Now, this here, meaning when I multiply this root 5 by root 5, it just gives me the square root of what? 25. But the square root of 25, we know that the square root of 25 is what? Is 5. That's why how we get the what? The 5, which is here. And also the 2, since here we were saying root 2 multiplied by root 2. So meaning the root 2 there just goes and you have the what? A 2 there remain. So that's a faster way of you what? Looking it than doing all this. Do you get it now?
Yes, I get it now.
Okay, all right. So we can proceed now since we are all on the same page. Okay, so our next question, which is here. So we have 1 over the square root of 2 plus 1 like this. Then I have this part, square root of 3 minus 1 like that. So I can write this as, so this will be equal to 1 multiplied by, so the first part I can write as 1 plus root 2 multiplying by, so this here means multiply 1 by root negative 1, sorry. So this negative 1 plus the root 3. I have rewritten this like this. Okay, so since you're multiplying, this on top will give you 1, and this will give you what this back when you are multiplying. So what you do now, you separately rationalize the denominator for each one of them. So we start with the first part, this one. Here we rationalize this one. So you have 1 over 1 plus root 2. I rationalize, meaning you multiply by the conjugate. So the sign there will change to negative root 2, then there 1 root 2. So on top we just have 1 root 2, then down 1 squared, so here to be 1 squared minus, then you have root 2 squared like that. This gives you 1 minus root 2, then divided by 1, then you have minus 2. And this gives us negative what? Negative 1. And this will just be 1 minus root 2 divided by negative 1. So that negative can divide into the 1, which gives us negative 1, and into that here, negative root 2 gives us a positive root 2. So this part here, when we rationalize this first part, we just get negative 1 plus what? Plus root 2, like that. So you keep this one. Let's keep this one. Okay, erase here. Then let's do that other part. So you have 1, then you have negative 1, you have plus there, plus root 3. This will be, so by the conjugate, that sign will change. So it will be negative 1, negative 3, negative root 3, then you have negative 1, negative root 3 there. So you're multiplying by this here. So in the numerator, you have negative 1, negative root 3. Then down there, you just have negative 1 squared minus the root 3 what? Squared, like that. Then you have negative 1, negative root 3, then divided by 1 minus, then this here gives you what? Gives you a 3. So then when you subtract, you just have negative 1, negative root 3. Then here you have a negative what? Negative 2. So the negative 2, the negative here can divide such that you just have 1 plus root 3 divided by what? By 2. So this negative divides with that, it divides with this here. So in short, what's going on here at this part is negative 1 divided by negative 2. Then you have negative what? Root 3 divided by negative 2. But you see these negatives, they cancel out, and you just have half plus root 3 and then 2. But then you have the same base, so you can keep the base and then you add what's in the numerator, which is this here. So this is what we get. Now we are multiplying, so we can bring them back now. We join everything together. So just have, okay, so like let's use blue. So we have this part, the first part here we had found negative 1 plus root 2 there, like that. And then the second part is just that the 1 plus root 3 over what? Over 2 there. And you're multiplying all this. So it's like you're multiplying over 1 here. So meaning down there you have a 2. Then in the numerator, what are you going to have? So this negative 1 multiplies by that 1. It gives us negative 1. Negative 1 multiplied by this root 3 gives us negative root 3. This root 2 multiplied by 1, it will give us, this will be plus root 2. Then you have this root 2 multiplied by the root 3, so it will be root 2 multiplied by root 3 there. So this is going to just be equal to, so this is just going to be equal to, so negative 1, you have there negative 1, then you have root 3 plus root 2. So this here you can write as what? The square root of 6, then over what? Over 2. And just like that, we have rationalized the denominator. So essentially what they mean when they're saying rationalize the denominator is remove this radical that you are seeing here, the radical that is in the denominator. It should no longer appear in your final answer. You see the radical is no longer there in the denominator. So that's what you do. Is there any question before we move on to the last question for this class? All right, so the last question. So the last question, you have root. Okay. So you have the square root of 3 plus 1 over the square root of 3 minus 1 plus the square root of 3 minus 1. They even tell you express this in the form. So when they ask you to express it in this form, a plus b root something, where a and b are rational numbers, what they're telling you is just rationalize the denominator here and get the form something like this. So we start with this first part. For now, forget about this part. Let's look at the first part here. So we can write that first part here as, so you can write that as 1 plus the square root of 3. Then down there, negative 1 plus square root of 3. Then now you multiply by the conjugate of the denominator. So the denominator there, you have negative 1. The sign there, positive, changes to negative, so it will be negative 3 since it's the conjugate. Then negative 1, negative 3 there. So what am I going to have? I'm going to have that when I multiply this first part, you have 1 multiplied by the negative there. So that gives you what? Negative 1. Then you have 1 multiplied by the negative root, that will be negative root 3. Then this root 3 by the negative gives you negative what? Root 3. Then you have this multiplied by the negative root 3. So negative root 3 multiplied by negative root 3 gives you positive root 3 multiplied by the negative root 3 will just give us a 3 there. Since I'm multiplying this square root of 3, this just gives us what? This just gives us 3. So as we said, the 3 here, you can write 3 times 3 is 9. And the square root of 9 is just 3. That's why we get 3 there. Then down there, since it's a conjugate, what you do, you just get the negative 1, you square it, minus the root 3, then I square it like that. So I'm going to have, okay, so I just have in the numerator, you have, so this negative 1 and this negative 3, you can add, you have a negative 4. Then this here, negative and negative, you can add also, you have 2, negative 2 root what? 3. Then divided by, here you have a 1, then minus, you have minus what? Your 3, like that. Okay, then next you're going to have negative 4, negative 2 root 3. Down there, subtract, you get a negative 2. This negative 2 you can divide into there and into there. So you have a 2 there, then that will be plus, becomes positive 3 like that. So this is what it simplifies to. Now, you can remember this part which we had forgotten about. So that part is this root 3, the root 3 minus what? 1. So this will be 2 plus root 3 like that. So you have 2 root 3 plus root 3 minus 1. So the minus 1 will subtract with the 2 there, which gives you 1. This and that will add, that will give you a 2. So it will be 2 root what? 3, like that. And just like that, you've expressed in this form, where A is a what? Where A and what and B are rational numbers. 1 is a rational number because I can write it in the form A over B as 1 over 1. It gives me 1. Then B is also a rational number because you can write it in the form like that. It's rational, like that, which gives you just 2. And then you have your root 3 here. So your root 3 is appearing here. Just like that, you've answered. Okay, I don't know if there's any question, but this is where we end with today's class.
I don't think there are any questions.
Okay, thank you very much. So I will send you questions that you should handle and do in the group. And then to those that will do them, you can send them to my inbox and I'll check if they're correct, like that. All right, we'll see you in the next class.
All right. Thank you, sir.
Yeah,
Thank you
welcome.
very much.
Now, these examples that are just proving that